Okay, so if you guys are watching this video, then that means that you already watched the video from yesterday about just plugging in solutions for systems of equations. So I zoomed out so you could pause the video and copy down the notes. And then once you copy them down, you can play, and then we're going to talk through them. So at this point, pause the video, copy down the notes. We are going to be graphing today, so if you have graph paper, preferably use it. If not, you can just draw the coordinate planes on your normal notebook paper. So pause the video now, write it down, write it in your table of contents, and then play the video when you're done. Okay. Alright, so today we are doing systems of equations. We are solving by graphing. So the three different ways that you're going to learn how to solve systems of equations is by graphing, by substitution, and by elimination. The standard is 8 EE 3.8, so this is an 8th grade scale. Now, we defined systems of equations yesterday. I might have changed the wording a little bit for the definition, but it's the same meaning. So what is systems of equations? Systems of equations, it's a set of two or more linear equations using the same variables. So yesterday, we saw that these were our linear equations, and they had the same variables. They used x and y in both equations. Now, could we switch the variables and use a and b? Sure. Most commonly, though, you'll see x and y. So it's a set of two or more linear equations. So you're going to have two different linear equations, equation A and equation B. Sometimes it'll be in slope-intercept form. Sometimes it'll be in standard form. Now, remember, linear equations. Those are equations that when you graph them, it's a line. Linear line. So these are going to be straight lines that we're graphing. And they both have the same variables. Both equations have x and y. Now this is crucial, and this is what we saw yesterday. So the whiteout made it change colors. Okay. The solution to the system of equations is an ordered pair. So the solution's an ordered pair. That is a solution of each equation. So what does that mean? Yesterday, we were testing the ordered pairs. Is 1, 5 a solution of the system? So the ordered pair, 1, 5, when we plugged it into both equations and solved it, it worked. We plugged in 1, 5. 1 plus 5 is 6. We plugged in 1 for x and 5 for y. Negative 3 plus 5 equals 2. Yes. So the ordered pair is the solution. That's important to know. What is the solution to the systems of equations? It's an ordered pair. And that ordered pair has to be the solution for both of the equations. So we have two steps for graphing equations, or graphing systems of linear equations. Two steps. Step 1. First, you have to graph each equation on the same coordinate plane. So we have our coordinate plane. We're going to have to graph both of these equations on the coordinate plane. That's the first step. Once they're graphed, we're going to find and estimate where they intersect. So if we have two lines and they intersect right here, whatever that point is the solution. So first we graph it, then we see where do they intersect. Now I wanted to review slope-intercept form. Hopefully you guys remember it. If not, that's okay. Slope-intercept form. What is slope-intercept form? Y equals mx plus b. So m slope. M is our slope. And remember, slope is rise over run. You rise, you go up or down, you change in Y, over run, change in X, left and right. Okay? And then B is, well, M was our slope, so B is the intercept. It's the Y-intercept. It's where it goes through the Y-axis. So B is when we're on the Y-axis. So we're going to do 4 practice problems that are very similar to ones that you'll see in Khan Academy. And then you guys will be ready to go do your Khan Academy Systems of Equations by Graphing. Guys, I cannot stress enough the importance of actually taking these notes. You're going to be held accountable for knowing this stuff next year in algebra. So, step 1, graph each equation on the same coordinate plane. So we have 2 equations. The first one is y equals x minus 1. Well, we know, so I'm going to put it down here, A. So what's our slope? What is our slope for equation A? Y equals x minus 1. The slope is in front of x. If there's not a number there, it's an invisible 1. So the slope is 1. Okay, and it's important to remember that 1 is the same as 1 over 1, because 1 divided by 1 is just 1. So that means we're going to rise 1, and we're going to run 1, because it's rise over run. Okay, Y-intercept. So our Y-intercept is B. What's in the B position? -1. Okay, so right off the bat to graph it, we go to the Y-intercept at -1. That means on the Y-axis, we go to -1. We go down 1, and you put a dot. Then we use the slope to graph the rest. We rise 1, we run 1. So rise 1, run 1. Rise, run, rise 1, run 1. Up 1, over 1. Up 1, over 1. Up 1, over 1. Up 1, over 1. Down 1, left 1. Down 1, left 1. Down 1, left 1. Okay, and then you can connect the dots. You can use a ruler if you have one, a straight edge, whatever you have. I'm going to use this piece of cardboard for my graph paper. Okay. So that is a line. That's the graph for the linear equation y equals x minus 1. Y-intercept at -1. The slope is 1. Up 1 over 1. Up 1 over 1. Okay, now we're going to talk about equation B. So we're going to talk about the slope, and we're going to talk about the y-intercept. Okay, so slope. Slope. What is in the M position? What is touching or in front of the X? A negative. What's the invisible number? There's an invisible 1 there. So -1. Okay, we know that's the same as -1 over 1. And slope is rise over run, so that means we're going to rise -1. So we're going to go down 1, right 1. Down 1, right 1. Okay, the y-intercept, what's in the B position? +3, +3. So immediately when you see a linear equation, first you put the dot at the y-intercept, the +3. So where are we on the y-axis? +3. Up 1, 2, 3. So y-intercept, that's where the dot is on the y-axis. Okay, then the slope, -1, so we rise 1, run 1. -1 over 1. So it's rise, it's -1, so we go down 1. +1, so we go right 1. -1, so we go down 1. +1, right 1. Down 1, right 1. Down 1, right 1. down 1, right 1. Now on Khan Academy, they're going to have it for you, the graphs where you can just move the lines and place some dots. So then you get your straight edge, connect the dots, okay, and that's the graph for our systems of equations. So we have in purple x minus 1, we have in pink negative x plus 3. So what is the solution? Where do the two graphs overlap? Right there. What is this ordered pair? Well, we went right 2, up 1. So the solution is right 2, up 1, so 2, 1. That is where both graphs overlap. That's the ordered pair where both graphs intersect. So that is the solution. How could you check that? Plug it in. So we plug in 2 for x and 1 for y. 2 for x. 2 minus 1 is 1? Yes. Okay, 2 for x. Negative 2 plus 3. What is negative 2 plus 3? Positive 1. So that's how you can check it quickly to make sure it works. Alright, so the next one we're going to do is in slope-intercept form again. So it's the same directions for all problems. Find the solution to the system of equations. And we're focusing on doing it by graphing. So they're both in slope-intercept form. Y equals mx plus b. Y equals mx plus b. So the easiest way for me just to start is I just like to label the slope and the y-intercept. So slope and y-intercept for both of them. That's all you really need to graph them when they're in slope-intercept form. Slope, y-intercept. Okay, so I challenge you guys to try to do this one ahead of me. Either pause it, try to fill these in your own, or think of it before I say it. So what is the slope for y equals negative 4x minus 3? What is the slope? What is m? Well, it's y equals mx plus b, so the m is negative 4. Negative 4. That's the same as negative 4 over what number? What invisible number is under all numbers? 1. Because negative 4 divided by 1 is just negative 4. So that means we're going to rise negative 4, so go down 4, run positive 1, so right 1. So that slope tells us down 4, right 1. Down 4, right 1. Okay, what's b? What's our y-intercept? Y equals mx plus b. So that means our y-intercept, oops, my bad, crap, negative 3. So remember, y-intercept, guys, is when x is 0. So it's at 0, negative 3. It's on the y-axis. So right off the bat, we can put this on our graph. So draw your y-axis. Oops. Draw your x-axis. So y, x. So first you start with the y-intercept, the negative 3. It's at 0, negative 3. We're on the y-axis at negative 3. 1, 2, 3. That's the first step. Then you follow the slope from the y-intercept, not from the origin, not from 0, 0, from the y-intercept. So the slope is negative 4. So down 4, up 1. I mean, rise over run. So down 4, right 1. Down, well, I don't have any more room because that's a new sheet. So instead of going down 4, right 1, we're going to go up 4, left 1. Up 4, 1, 2, 3, 4, left 1. Okay. So that's how we graph. Y equals negative 4x minus 3, because our y-intercept is at negative 3 and our slope is down 4, right 1, or up 4, left 1. And we know it's a negative slope because the line is going this way, so you would be running down it, decreasing, so negative. Alright, so now try to graph. Try to figure out what is the slope for negative 2x plus 1 and what is the y-intercept, and then try to graph it on your own. Is this blurry? I feel like it's blurry. There we go. Okay, slope. Y equals mx plus b. Y equals m. So our slope is negative 2. Okay, that's the same, guys, as always over a positive 1. So, rise over run. We're going to go down 2, right 1. Down 2, right 1. Y-intercept. Y equals mx plus b. B is our y-intercept at positive 1. Remember, your y-intercept is when your x is 0, so 0, 1. Okay, so take that in. Negative 2 is our slope. 1 is our y-intercept. 1 is our y-intercept, positive 1. So we're on the y-axis at positive 1. Then we follow our slope, negative 2. So down 2, right 1. 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 If you can go down 2 and right 1, you also can go up 2, left 1. Up 2, left 1. Up 2, left 1. Use your straight edge. Connect the dots. Okay, so step 1, graph both graphs, graph both equations on the same coordinate plane. Step 2, find where they intersect. Where do both graphs overlap? Right there. What is that pair? What is that ordered pair? Well, the solution is, so we went from the origin, left 2, down, oh my goodness, left 2, so negative 2. Negative 1, negative 2, up 1, 2, 3, 4, 5. So that's at negative 2, 5. That is our solution. Negative 2, 5. How can you confirm that that is right? You could plug it back in. So negative 4 times x, negative 4 times negative 2. Negative 4 times negative 2 is positive 8. 8 minus 3 is 5. That x is here. Negative 2 times x. Negative 2 times negative 2 is 4 plus 1. 4 plus 1 is 5. So you can confirm that it's right before you even, I love when you can confirm that you're right, because then there's not a guessing game. That's amazing. So these two are in slope-intercept form. Sometimes you'll see them in slope-intercept form. So you use the y-intercept and the slope to graph. Now, the last two that we're going to do are in standard form. Okay? Standard form. ax plus by equals c. ax plus by equals c. Okay? So we each have a form that we prefer. I prefer y-intercept form, or slope-intercept form. But that's okay, because we have to do both. So, let's recall how we do standard form. So if you guys are being good and you're actually using your notebooks, then you could turn back to standard form on page, let's see, when do we do standard form? Standard form, page 45. So you could go back to page 45 in your notebooks when we did it in January. Or you can just watch this video and have it all come back to you. So, I hope this is the same. Yeah, it is. Okay. So negative 3x minus 9y equals 18. So we're going to have to find our x-intercept and our y-intercept. That's the easiest way to do it in standard form. X-intercept and y-intercept. Let me draw my graph. Not that I have to do that first, I just want to plot it right away. So you draw your y and x-axis, y, x. Okay. So x-intercept and y-intercept. Well, we know our x-intercept is when our y is 0, and our y-intercept is when our x is 0. X-intercept, you're on the x-axis, so your y value is 0 because you don't go up or down. Y-intercept, you're on the y-axis, so your x is 0 because you don't go left or right. So x-intercept is when your y is 0. So if we plugged in 0 for y, negative 9 times 0 is 0. It goes away. So that basically leaves us with negative 3x equals 18. Negative 3x equals 18. So think about it. When you're trying to find the x-intercept, just cover up the y, because y is 0. Negative 3 times what number equals 18? Negative 3 times what number equals 18? Negative 6. So our x-intercept is at negative 6. 1, 2, 3, 4, 5, 6. Negative 6, 0. We're on the x-axis. Y-intercept. Y-intercept is when x is 0. Negative 3 times 0 is 0. It goes away. So y-intercept, you cover up the x. Negative 9 times what number equals 18? Well, we know 9 times 2 is 18, but it's negative and positive. So negative 9 times what equals 18? Negative 2. Y-intercept, y-axis, negative 2. Okay? So you don't even need to find the slope. You could do change in y, how much did the y's change, over how much did the x's change, but you don't have to. Because you can just connect the dots. Step 2 said graph it and then find estimate. So we're just going to try this. Let's just try to estimate it, and I haven't done this before, so let's just see how it goes. Whew, I'm a little nervous. Okay. Brown. B. Okay, so we need to find the x and the y-intercept again. So x-intercept is when our y is 0. Y-intercept is when our x is 0. X-intercept, y is 0. X-intercept, we cover up the y. We're solving for the x-intercept. 4 times what number equals 9? 4 times what number equals 9? So that's 4x equals 9. 4 times what number equals 9? Well, divide by 4. Divide by 4. X equals 9 over 4, which is the same as, how many times does 4 go into 9? 2. With 1 left over, 2 and 1/4. And 1/4 is just a quarter, so 2.25. Okay? I have my statements notes here, and I'm just checking because I don't want to mess up on this. Did I write the wrong equation? I did. I wrote the wrong equation. This is supposed to be 12. That's okay. That's okay. So, 2 1/4 or 2.25. Okay? 9 over 4. So, 2 1/4, 0. 1, 2, and a little bit, 0. Okay? Y-intercept when x is 0. So 3 times what number equals 9? 3 times 3 equals 9. So 0, 3. Okay, well, I actually don't know the solution to this one, so let's graph it. Connect the dots. So, this is my mistake. They connect right here. They intersect right here. So it's at 1, 2, 3, 4, 5 for the X. -1, -2, -3, and a little bit. I'm just gonna go with this. So if 5 is for the X, well, let's see, 4 times 5 is 20. So 20 plus 3y equals 9, minus 20 minus 20. So that leaves us with 3y equals, what's 9 minus 20? I'm just going to check it in my my calculator, even though it should be -11. It is. Divide both sides by 3. It's -3.66666. So that means that this point right here is 1, 2, 3, 4, 5. So it's 5, and then it's -3, and I know that's 2/3. -3 2/3. Okay, that should not have happened. It should have been a beautiful answer. That's my mistake. My apologies. The next one will be way prettier, because I'm going to check my equation before we solve it. Okay, it's perfect. So, the important thing to know is you graph them. So Khan Academy, you'll just be able to adjust the lines, and then you find out where they intersect. So let's do the last one together. I'm going to draw a line to separate this. Okay. 21x plus 7y equals 42. So, X-intercept and Y-intercept. Okay, X-intercept. X-intercept is when our y is 0. Y-intercept is when our x is 0. So X-intercept is when our y is 0. So we cover it up. 21x equals 42. So 21 times what number equals 42? 2. So 2, 0. Okay, Y-intercept is when our x is 0. So we cover up our x. 7 times what number equals 42? 7 times what number for y equals 42? 6. And you can always check it in your calculator if you're not sure. 6. Okay, so then we put our graph. X-intercept is at 2, 0. Y-intercept is at 0, 1, 2, 3, 4, 5, 6. Alright, now we do it for connect the dots. So, personally, this is my least favorite way to solve systems of equations. That's why we're knocking it out of the way first. Also, I don't really like graphing in standard form, but tough. Alright, B. X-intercept, Y-intercept. Okay, X-intercept is when our y is 0. Y is 0. X-intercept, y is 0. Cover it up. -5 times what number is 10? -5 times -2 is 10. So -2, 0. X-intercept, we're on the x-axis. Y-intercept is when our x is 0. X is 0. Cover it up. 5 times what number is 10? 2. 0, 2. We're on 2 at the y-intercept. We're 2 on the y-axis. Okay, connect the dots. Much nicer this time. It just goes right through it. I feel so bad about that one. That's okay, that shows that you can estimate it, because that's clearly not 2/3 down, but it is what it is. Alright, so where do these overlap? Right here. So our solution is at 1, 1, 2, 3. So solution, let me zoom out. Solution it's where two lines intersect. It's the ordered pair. 1, 1, 2, 3. Because this is 1 on our x-axis and 3 on our y-axis. Okay, how could you check that? You plug it back into both equations, because this ordered pair should be a solution to both equations. So let's plug in 1 for x. 21 times 1, so 21 plus, uh-oh, you're joking. Did I mess up again? No way. 21 plus 7 times 3. Oh, it's 21 plus 21. Oh my goodness, I was freaking out. Okay, negative 5 times 1, so negative 5 plus 5 times 3. Negative 5 plus 5 times 3 is 15, so negative 5 plus 15. Negative 5 plus 15, 10. So that confirms right there that it works. I'm going to check this one just for my own sanity. Times 5 minus 9 times 3 negative and 2/3. Yeah, okay. Alright, so sorry about that mishap, but don't panic, don't stress. Khan Academy makes it very nice and easy to graph these for you. So you need to know how to figure out the X and Y intercept for standard form. Put the 2 dots there, and then the line will follow. For slope intercept form, you just do the Y-intercept and slope, and then you find where the graphs intersect. So now you guys have enough information to start solving systems of equations by graphing. Contact me if you have any questions, and sorry this video is so long.